All right, here we are with lesson 2.06, Compound Statements, Part 1. Please don't forget to add your course and section number with all communication to me. So that would mean if you leave a phone message, if you send me an IM, you send me a K-mail, I need your course and section number. Don't tell me you're in geometry because I have a lot of geometry classes. The objectives of this lesson, I've lost my pointer, are to identify and create truth tables for conjunctions, disjunctions, and compound statements, to identify and write compound statements including conjunctions and disjunctions, and understand the difference between inclusive OR and exclusive OR. Some terms that we're going to be looking at in this lesson are compound statement, conjunction, disjunction, the inclusive OR, and the exclusive OR. Let's just do a quick review of our conditional statements. Remember, following the if is the hypothesis, following the then is the conclusion. Your converse is flipping the hypothesis and conclusion. Your inverse is negating the hypothesis and conclusion. And your contrapositive is switching them and negating them. And here's the symbols that you're going to be using: to P for hypothesis, Q for conclusion. The arrow means implies, and the little tilde mark means not. And here's a quick look at the tables. Y'all know these slides are always, or I think they're even already available, I'm not positive, in Doc Sharing, so you can go and review these tables at your own time pace. So let's look at a compound statement. It connects two statements with either the word and or the word or. Okay? These compound statements are not different from the compound statements that you've learned in English. Okay? If they are connected by the word and, it's a conjunction. If they're connected by or, then it is a disjunction. So here we've got a conjunction, and this little up arrow right here, see it right here? It's a little caret that a lot of times we use when we're using exponents. Okay? That tells me that it's going to be a conjunction using the word and. And the way I let it help remind me is this looks like the letter A without the horizontal mark. A for and. Okay? So Snoopy wears goggles and scarves. It is not the case that Snoopy wears goggles and scarves. So seeing the word not, see how I wrote this? The tilde is outside the parentheses and the P and Q are in the parentheses. It's got to be that way. Alright? It has to happen that way. Now here's a disjunction. Now if I think of this little caret here as an A, then I think of this one that's upside down as or. There's nothing to help me remember except that if it's upright, then it's A. If it's upside down, then it's going to be or. Okay? So P or Q, I don't know why this is coming out like this, but there should be an I there. It says, I will paint the room blue or green. And this one says, it is not the case that I will paint the room blue or green. Alright, so those are examples of your conjunction and your disjunction. And what I'm going to do now is, and I hope you enjoy this, is show you a little video from Schoolhouse Rock that talks about the conjunction and the disjunction. And sometimes when you see things like this, it helps it stick in your brain. So give me just a moment and I'm going to get this video started for you.
Conjunction, junction, what's your function?
Hooking up words and phrases and clauses.
Conjunction, junction, how's that function?
I got 3 favorite cars that get most of my job done.
Conjunction, junction, what's their function?
I got and, but, and or, they'll get you pretty far. And an additive like this and that. But that's sort of the opposite. Not this, but that. And then there's or, O-R, when you have a choice like this or that. And but nor get you pretty far.
Conjunction, junction, what's your function?
Hooking up two boxcars and making them run right. Milk and honey, bread and butter, peas and rice.
Hey, that's nice.
Dirty but happy, digging and scratching, losing your shoe and a button or two. He's poor but honest, sad but true. Boo-hoo!
Conjunction, junction, what's your function?
Hooking up two cars to one when you say something like this. Choice, either now or later, or no choice. Neither now nor ever.
Hey, that's clever.
Eat this or that, grow thin or fat. Never mind, I wouldn't do that, I'm fat enough now.
Conjunction, junction, what's your function?
Hooking up phrases and clauses that balance like out of the frying pan and into the fire. He cut loose the sandbags, but the balloon wouldn't go any higher. Let's go up to the mountains or down to the seas. You should always say thank you or at least say please.
Conjunction, junction, what's your function?
Hooking up words and phrases and clauses in complex sentences like in the mornings when I'm usually wide awake, I love to take a walk through the gardens and down by the lake, where I often see a duck and a drake. And I wonder as I walk by just what they'd say if they could speak. Although I know that's an absurd thought.
Conjunction, junction, what's your function?
Hooking up cars and making them function.
Conjunction, junction, how's that function?
I like tying up words and phrases and clauses.
Conjunction, junction, watch that function.
I'm gonna get you there if you're very careful.
Conjunction, junction, what's your function?
I'm going to get you there if you're very careful.
Conjunction, junction, what's your function?
I'm going to get you there if you're very
All right, now granted that video was done for English, but it works for us too. The only thing is we don't use the word but. We just have and or. But it's a nice video to help you remember the good old days. All right, now let's look at truth tables for compound statements. A conjunction is true only when P and Q are both true. Check that out, okay? Because Scooby wears a, I forgot what he was wearing. He was wearing a scarf and a cap, I think. So he wasn't wearing one or the other. He was wearing them both. So if he's only wearing a scarf, then it's not going to be true, okay? So a disjunction is false only when P and Q are both false, and you can see that right here. Otherwise, the compound statement is true. And y'all know things like this are always better with examples. So here's our instructions. For each pair of statements, do the following. Write a conjunction connecting the pair of statements. So that means we're going to use the word and determine whether the conjunction is true or false. And if it's false, let's do some explaining. Here's our sentence. All squares are rectangles. All equilaterals are isosceles. So let's see how they wrote out the sentence, the conjunction. All squares are rectangles and all equilaterals are isosceles triangles. Okay, so then you have to decide if that's true or not. Well, all squares are rectangles, that's true. All equilateral triangles are isosceles, because remember, for an isosceles to work, at least two sides have to be congruent. Well, an equilateral has all three sides. So this conjunction would be true because both P and Q are true. Here's another one. 3 is a prime number, 4 is a perfect square. 3 is a prime number and 4 is a perfect square. So you have to remember what a prime number is. It's only divisible by 1 in itself. So 3 is a prime number, and the square root of 4 is 2, so it is a perfect square, so this one's going to also be true. Now this instruction says write a disjunction connecting the pair of statements and then determine whether it's true or false. It says every square is a rhombus, every triangle has 3 sides. So writing it as a disjunction, it's going to say every square is a rhombus or every triangle has 3 sides. Well, you know what? It is true that every square is a rhombus. Okay? It's also true that every triangle has 3 sides. So it's going to be a true disjunction. Alright, another disjunction. A triangle can have 2 acute angles. A triangle can have 3 acute angles. Oh, looky there. I didn't put in what was supposed to be there, so let's go back. Well, let me see what's on the next slide. Nope, I don't like that. Okay, so let's look. Let me get my typewriting skills going here. Let me bring this down and change this to white so it'll show up. Okay, there we go. I went ahead and typed the information up here. So when I take these 2 sentences and put the word or in there, it says a triangle can have 2 acute angles or a triangle can have 3 acute angles. So yes, a triangle can have 2 acute angles and a triangle can have 3 acute angles. So both of those are true, so the disjunction will be true. So I can skip through that part. Alright. For each statement, determine whether it's a conjunction or a disjunction. A square pyramid has 5 faces and a rectangular prism has 6 faces. So remember, when you have the word and, it's going to be a conjunction. The Pythagorean theorem is used to find the length of one side in a right triangle, or the distance formula is used to find the length of a side of a square. So remember, when you have the word or, it's a disjunction. This says state whether the disjunction is an example of the use of the inclusive or the exclusive or. And we really didn't talk about that a lot in the lesson, but you'll see more information about it in the LMS. If you are a fan of the Mets or the Yankees, then you are a fan of a New York baseball team. And that's an inclusive or. So now we got to complete the truth table. And now remember, upright caret like this, just pretend it's the letter A for and. And remember, the only time your I'm sorry, my brain went blank. Your conjunction is true is both when P and Q are true. Alright, and then the rest will be false. Okay, what we learned in today's lesson: compound conditional statements are those in which the hypothesis has 2 parts. If the parts of the hypothesis are joined by the word and, the conditional statement is a conjunction. If they are joined by the word or, then the statement is a disjunction. The inclusive or means that it is possible for both parts of the hypothesis to be true simultaneously. So I can be a fan of the New York Yankees and the Mets. Not. And the exclusive or means that it's not possible. So I would say it was an exclusive because I'm a Texas fan. Mathematicians use the inclusive or. Okay. You should be, this should say 206. You should be reading through that lesson in the LMS, completing the student guide, checking out the pages in the reference guide, and then complete the following problems 1 through 27 odd before you take quiz 2.06. And if there's anything you don't understand, please let me know so that way we can make sure you understand it before you take the quiz. And that's it for lesson 2.06. Thanks for listening.